Now here's a shot we made later to illustrate to Bell engineers what was involved inside the helicopter, and it shows parts of the transmission in the very first machine. This is the freewheeling, which those of you who know Model 47 will recognize right away, except that instead of 16 slots, we later had to go to 32 slots for those rollers. Now, Arthur had thought that Bell would be able to provide him with transmission designers who would know far more than he did. But to his surprise, Bell was unable to help at all with the transmission, so Arthur merely made a copy of his same transmissions he'd used in the little models. But this is 6 times larger in size, otherwise almost identical to the model techniques. The transmission is a double planetary with free floating pinions. Here the freewheeling is almost assembled, and as you see, it is the ring gear for one of the stages of the double planetary, so that in one direction it was perfectly free and in the other direction it would lock up, similar to the coaster brake on a bicycle. Now here are the 2 planetary stages. The one on top happens to be the lower one at higher RPM and lower torque, and the bigger pinions on the bottom of the upper stage driving the mast. Now every new project, of course, has to have a ceremony of rollout with dignitaries, and we had to have ours. So came the day, exactly 6 months after we got to Gardenville, that we had what we called our official rollout. And the girl on the left there is going to try to break the champagne. The second try, she makes it, and we're ready for the big moment. Those 2 landing gear legs have been put on after the nose got out the door because they're much too wide for the door. We managed to get it out, but we were unable to start the engine, and so ignominiously it had to be towed back by my car into the garage. You can see we had pretty good winters in Buffalo even back then. This is December 18th, just over a year after we got to Bell, and 6 months after this project in the garage was started. Now here's a later rollout, and we've learned the drill of how to put the legs on much better at this point. The garage is still a Chrysler agency. It was restored to its original purpose after the Gardenville project was finished. The Gardenville project lasted exactly 3 years, from June of 1942 to June of 1945. The agreement that Arthur had with Larry Bell was to make a one-place helicopter to demonstrate the principles, and then later to make a 2-place helicopter so Larry himself could get a ride. Details of the landing gear are rather amusing here. You notice the black tube at the bottom there is a tension member, and then outboard there is shock cord so that we get a resilient effect. You can see the fuselage is hardly completed, but there is a wooden bench for the pilot operator to sit on, and the object here, of course, was just to get the engine running with the rotor and make sure we had a compatible mechanism without large oscillations. That's just the dolly that we wheeled it in and out on, and there's a pretty good view of the test bed in the configuration where we got the first mechanical problems solved. That shows how the rotor is free to move in a seesaw direction. Here's our auxiliary power cart, a mighty APU, consisting of 2 batteries in series. And by this means we managed to give the rotor engine enough of a kick to start. Now we had no clutch at this point, but we could rotate the rotor ahead of time on the freewheeling, which we did, so that there was possibility that the poor engine could get started without all the inertia of the rotor. Nobody in the cockpit, you notice, not exactly recommended these days, but you can see that we're trying to work on getting the mechanism to run properly. We had a lot of trouble with the carburetor and torsional oscillations at first. Now here Arthur Young's trying his own helicopter, sitting in on that bench and testing out the controls to see if their sensitivity is about right and so forth. We're holding him by ropes, again attached above the center of gravity, to prevent him from sliding and slithering around too much. But he wanted to see, of course, right away whether we had about the right power, right control sensitivity, and so forth. Now that's just to illustrate the amount of wind in this case, because our first problem immediately encountered was very severe vibrations whenever he was hovering in a breeze of about 20 knots or so. We always said he flew about 3 feet up here, but he never quite got that 4th foot off the ground. About this time we had our first setback. We had a visit from a Bell executive who was a pilot, who felt that he should be the one to make the first flight. And so he came to join us one day near New Year's of 43. And here he is without his safety belt fastened, and he's holding on by means of the controls. Now watch very closely, because we're going to have our first bad episode here. He's thrown up through the rotor. He landed in a snowbank to the left there, and fortunately his injuries were limited to a broken left arm just above the wrist. In fact, in a matter of only days, he was able to go about his business. But we were set back considerably, and took us a little while to rebuild our test bed. Here it is rebuilt. Notice that the engine is flexibly mounted in the pylon there, and that it's a vertical installation very similar to where the electric motors for the models had been, right in the center with the shaft vertical, which was part of our development problem I referred to earlier. This shows a little bit later in spring, and Arthur Young will show the throttle in his right hand as he twists it, and the lever in his left hand is known as the pump handle collective. We'll explain more about that later.